Guys, today we're going to see something called as data types. First, let's see what is data type. Okay, data type is used to create different types of variables. Okay, I'll tell you what is variable first. Okay, uh, in your programming, right, when you're doing coding, you will need to store your values intermittently. Because when you're manipulating something, or else you may want those values to be used later. Whatever you have calculated in the start of your program, you may want it later. For any number of reasons, you need to store your values in the memory, okay, so that it can be used later. Okay, those memory holders, right, those are called as variables. Okay, where you store your values. Okay, and data types is just a concept. Okay, data type is nothing but used there are different types of data types, so that you can create different types of variables. Like when I say different types of variables, right, now in your program you can either have a character, you can have a string, you can have a real number, you can have a whole number. When you say real number, right, real number is nothing but if you have a decimal point, it is called real numbers. When you say 2.4, 2.35 or something like that, which has a decimal value, it is called a real number. A whole number is nothing but 1, 2, 3, 4, 5, 6, and that's just a whole number. Okay, so you can have you can have anything in your variable, like a whole number, real number. You can even have a boolean value. When I say boolean, it's just have either true or false, character, a whole string. All these are like different types of variables which you will be using in your program. Okay, before once we are done with the session, right, you will exactly know what I was talking, what the definition I just gave. Okay, so don't worry about if you don't understand the definition. At the end of the session, this definition will make sense. Okay, before going into the data types and variables, right, I just wanted to cover one more topic, which is related to variables and data types. Okay, now you might have heard plenty of times in the computers, right? Everything the computer does in binary. Whatever you do, right, it doesn't the computer doesn't get it all. It can understand only one language, which is binary language. Okay, which is two. Okay, binary language is nothing but ones and zeros. Okay, that's called they call it as binary language. Okay, so let's see how that works. Okay, when I say when I say a variable, right? Okay, say for example, a variable has got a value of like 5 or 6 or 10 or 15. Okay, that is a whole number. Okay, I'll call it that is a whole number. Okay, but the computer, right, it can't understand whole numbers. It can understand only binary language, binary digits, ones and zeros. Okay, so that whole number, right, that needs to be converted into a binary, into a binary data. Okay, I'm going to show you how that is done, and how opposite is done. How a whole number is converted into a binary, and a binary is converted into a whole number. Okay, and that is how the computer works. Also, that's how the computer stores everything in its memory or hard disk or anything. Okay, and I will tell you later on in the class why I showed you how it's getting converted and why it is important. Okay, first let's see how it is converted. Okay, how it is represented in the computer language. I'm just going to open. Okay, now, okay, let's just before going into this thing, right, I'll tell you what is base. Okay, so when they say binary is base 2, okay, they will tell like that. And the decimal values, right, they are base 10. Okay, I'll tell you why it is base 2 and why our normal numbers are base 10. Okay, so why they call it as base 2 is because there is only two in a binary language, right, there is only two characters available for you to represent the whole thing. It's 1 and 0. And what is the count of it? 1, 2. Okay, there is only two characters available for you to represent the whole thing. That's why they call it as base 2. Okay, in our normal day-to-day math, decimal, right, how many digits we have got? Okay, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10. Count is 10. Okay, so that's why they call it as base 10. Okay, so when I say decimal to binary and binary to decimal, right, they will call it as base 10 to base 2 and base 2 to base 10. Okay, it's nothing but just decimal to binary, binary to decimal. Okay, now let's convert some values from base 10 to base 2, okay, which is decimal to binary. Okay, let's take first for an example, let's take a small number, okay, 8. Okay, now let's see how this 8 can be converted into a binary. Okay, all you have to do, if you in your childhood you would have heard something called as LCM. It's just division. Okay, all you need to do is like now divide this by 2. Okay, if you divide by 2, like now what you'll get 4. Okay, which is remainder is 0. Just write it like this. Okay, and then if you divide this by 2, right, what you'll get again a 2, which is remainder is 0. Okay, now again if you divide this by 2, what you'll get 1 and remainder is 0. Okay, so 8 is represented as 1 0 0 0. Okay, and they'll do it like this. Okay, so 8 is representation of base 10, which is decimal value. I just explained what is base 10 means. Okay, and then this is the binary representation of 8. Okay, which is so when I say binary representation, this is the base 10 representation. This is the base 2 representation. Okay, decimal representation, binary representation. Okay, it's really simple. It works out for how big a value you got. Okay, if you take for example something like 73. Okay, if you divide by 2, right, what you will get, you'll get 36 with remainder of 1. Okay, because 36 is 72 and you get remainder of 1. Okay, now again you divide this by 2, you get 18, which you have remainder of 0. Okay, again you divide by 2, which you'll get remainder of 9, and then remainder is 0 again. Okay, again if you divide this by 2, you get 4, which remainder of 1. Okay, again you divide by 2, you get 2, remainder is 0, and then you get 2, you get remainder 1, it's 0. Okay, because the end is always will be 1, because 2 divided by 2 is always be 1 and 0. Okay, now how this representation works is like now, okay, 73 base 10 equal to 1 0. You should come from this way. Okay, this is the direction you should go. Okay, I'm not very good with this pen. Okay, writing it. Okay, so it should start from here. It shouldn't start from here. Okay, it should start from here. Okay, so 1 0 0 1 0 0 1. Okay, and this is representation base 2. Okay, so this is how it is represented. Okay, 73 if you say 73 in your program, right, the computer understands this as 1 0 0 1 0 0 0 1. Okay, so why it will be always be 1 and zeros, right? Because you are doing the division by 2. So if you take any mathematical value and divide it by 2, means like now you'll always get a remainder. Either you'll get a remainder of 0 or a remainder of 1. Okay, there is no other way. Okay, so that's why you will get 1. That's why it's called base 2, and then that is a representation of this one. Okay, now I hope you guys understood how you can convert a decimal to binary. Okay, let's do the reverse thing. Okay, let's try to convert this binary into a decimal value. Okay, I'm just going to erase this one. Okay, now, okay, what we saw is like now we saw 8 base 10 is equal to 1 0 0 0 base 2. Okay, let's convert this into a decimal value. Okay, 1 0 0 0. We're going to convert this into a decimal value. How you will do it is, okay, first do is you should always start from 2 to the power 0. Okay, into whatever you got here. Okay, into 0. Okay, do the same thing. It goes on increasing. Okay, 2 to the power into 0, 2 to the power 2 into 0, 2 to the power 3 into 1. Okay, because it's 1 here. Okay, so now what you'll get 0, because anything multiplied by 0 is 0. Okay, so 0 again, you get 0 again, here you get 8. So if you add everything, what you'll get is 8. So this is how the conversion works. Okay, it's really simple. We will just see one on bigger value also. Okay, I'll just erase this one. Okay, let's take something like 99. Okay, and then how? So if you do it, 99 is 49. Okay, and with the remainder of 1. Okay, again you do it by 2, you get 24 with remainder of 1. Again you do it by 2, you do 12, remainder of 0. Okay, again you do 2, get 6, remainder of 0. Again you do 2, you get 3, with the remainder of 0. Again you do 2, you get 1 with the remainder of 1. Okay, so the representation is 1 1 0 0 0 1 1. Okay, because it's always should go this direction and then this direction. Okay, when you take the numbers. Okay, now let's convert this into a decimal value. See, okay, so what I said was you should always start from 2 to the power 0 into multiplied by 1. Okay, and it goes on like this. 2 to the power 0. So I think I can just yeah, so 2 to the power 1 into 1. Okay, now then 2 to the power 2 into 0, 2 to the power 3 into 0, 2 to the power 4 into 0, 2 to the power 5 into 1, 2 to the power 6 into 1. Okay, now let's do this one. Okay, so 2 to the power 0 is always, it's always going to be 1. Okay, anything powered by 0 is always 1. Okay, that you can that we can remember easily. Okay, so it's always 1. It will be 2 to the power 1. 1 is 2. 2 into 1 is 2. Okay, anything multiplied by 0 is 0 0 0. Okay, 2 to the, okay, 1 second, 2 4 8 16. Okay, 2 to the power 5 is 32, and then 2 to the power 6 is 64. Okay, let's add all these things. Okay, 1 2 3 5 and then 9. 3 plus 6 is 9. You get 99. Okay, this is how the binary conversion works. Okay, there is a big reason why I showed you guys this thing. Okay, because this 99, if you say 99, right, in the memory, when I say memory means like, no, I'm always talking about the RAM. Okay, where all your programming is internally stored. Okay, when you run it. Okay, when I say 99, right, to represent that 99, right, your Java programming, right, it's going to need all these bits. When I say a bit, right, this is 1 bit. Okay, this is represent either 1 or 0 as a single bit. Okay, that's what they that's a memory, that's the basic least memory where it stands from. Okay, now, okay, this is representation of a single bit. Okay, it's not going to, it's the Java program, right, it's going to need 1 2 3 4 5 6 7. It's going to need 7 bits to represent this value 99. Okay, that's just basic. Okay, it's a common thing. Okay, now let me minimize this one and go back to Notepad and explain it how we can do this. Now I just write it. Okay, so we are seeing data types now. Okay, first we talked about bit, right? Okay, 1 byte is equal to 8 bits. Okay, that's the basic thing. Okay, and then everything is 1024. Okay, after here afterwards. Okay, 1 KB equal to 1024 points. MB is equal to okay, and then keeps on terabyte, petabyte. You all know those things. Okay, now, okay, so in our when we do the programming, right, we are going to do only pretty much we need to know about the bytes. Okay, we never use kilobytes or megabytes to store our data in. Okay, because there's not going to be, you're never going to use a use a variable or value which requires 1024 kilobytes. Okay, so all we really important thing is like, no, we are going to pretty much deal only in bytes. Okay, now now let's do this one. Okay, now from this one, what I told you was like, no, for to do the 99, right, we need 7 bits. Okay, so let's see what is the maximum value we can store it in a single byte. Okay, let me clear this board. Okay, when I say a single byte, like, no, it has got 8 bits. That's what I told here. Okay, a single byte can have 8 bits. Okay, now, okay, so in a byte, right, so all the what is the maximum value you can have is like, no, you can have all as 1. Okay, so when I say all as 1 means like, no, you can have 8 ones. Okay, 1 1 1 1 1 1. Okay, whenever I type anything in a binary, right, I always do it in a fraction of 4. I mean, when I say fraction of 4 means like no, after 4 characters I just give a space so that like no we can see it clearly. Because if I do 8 means like no, it's really hard to count. If I do 8, so that's why I give space always 4. Okay, so this represents the 8 bits. Okay, and this is the maximum value you can store it in a 8 bit. Okay, when I say 8 bit, this is the maximum value you can store it in a byte. Okay, let's convert this one and see into a what this value will be. Okay, for that I'm not going to do the traditional way, because if I do it in traditional way, it will become too big. Okay, so I know for this one, like now, the maximum value what you can have is 255, I think. Actually, let's do it in a calculator. Okay, okay, it's already in this format. Okay, I need base 8. If I do 255, okay, you see this one, right? I'm not sure if we can zoom it or okay, don't worry about it. Okay, if I do 255, what you see here is like now you see this, right? All are ones, right? So if you in a single byte, this is the maximum value what you can represent. Okay, when I say maximum value represent, right, you can have if you are declaring a variable as byte means like no, you can have maximum is 255. You can't have 256 because you can't represent 256 in a byte. If you want to do 256 in a byte sorry, if you want to represent 256, like no, you need 9 bits. You need a byte and an extra bit as well, so which you can't do. So in a single byte, if I say, it means like no, you can have only 255 as a maximum value. There's another bit caveat to here actually. Okay, when I say a whole number, right, you can have something called as negative numbers as well. Okay, when you're doing calculation, when you're doing programming, right, you can have either negative value or positive values. Okay, how they have designed Java is like no, they have reserved this most significant bit for they call it as a sign bit. Okay, if it says 1 means like no, it is a negative value. If it says 0 means like no, it's a positive value. Okay, so what are the bits available for you to represent your values? Like no, these 7 bits only, because the most significant bit is always reserved for the signature to represent the sign. Okay, so these are the only bits available for you to represent your values. So you got 7 bits to represent your values. Now recalculate this one. Okay, because here we have done 8 bits. Okay, now recalculate this with 7 bits. Okay, now I know for sure that like no, okay, let me come. So 127 is a maximum value which you can store in with 7 bits. Okay, forget about this bit. Okay, so 1 2 3 4 5 6 7. Okay, with 7 bits, right, you can have only 127. Okay, now what is the thing is like now you can have either minus 127 or plus 127. Okay, so sorry, okay, in a byte, right, as I said, the most significant bit is reserved for the binary to represent the signed bit signature, and then the next 7 bits is used to store your values. So because of that restriction, because of that thing, right, in a single byte you can have values from I will tell you why it is. Sorry, I'm not going to tell you the value is going to be minus 128 to 127. This 120, you can ask, okay, it should be minus 127 to 127, right? You got 7 bits only right now, because there is a concept called as 2's complement. If you have free time, right, I would not recommend it to see it, but if you're really curious, you can see what is 2's complement means. Okay, because Java program or any program, C program or C++, everything uses everything uses 2's complement to represent the negative values when storing it in the memory. So if you go deep, right, it will be a bit confused, but you will be able to clearly understood why you can use minus 128. Oh, it's not minus 127. Okay, just for now, like just think that minus 128. Okay, now so in a byte, right, we know why you can't have 255, because the most significant bit is reserved for the sign bit. So only 7 bit is available for you to store your data. So the maximum value what you can have is 127. The least value what you can have is minus 128. Okay, so this is how the architecture works. Okay, this is the basic thing. Okay, in a byte, right, in a variable which you have declared as 1 byte means you can have value from minus 128 to 127. Okay, so this is the basic concept of the storage of the data in the memory. Okay, now I'm going to go into the topic of what are the different type of data types you got. Okay, data types. Okay, different types of data types I'm going to say. Okay, I'm going to first type all the things and then I'm going to explain what is everything. Okay, float, and then you got what's the next thing? You got short, you got int, on, you got float, you got double, you got character, you got boolean, you got string. I will tell you why this is capital letter and string is alone is a different type. It's not your regular data type. Okay. Now, float is got. Just make this. Sorry, you don't need the float. I'll tell you. I'll tell you why this definition is. Okay. Now, first. I'll write down what are the maximum things. I think before short there is something called byte as well. Okay, now, okay, this has got 1 byte, this has got 2 bytes, and this has got 4 bytes. This is 8 bytes. 8 bytes, 2 byte. This doesn't have any space because you can have some people say it has got only 1 bit actually, but that's not true actually. The reason is like no, you can have either true or false in a boolean. Okay, that's why they call it as. And string also doesn't have any static predefined bytes. Okay, it can dynamically increase and dynamically reduce. Okay, I will talk about why these two are different. Okay, now. So this is the basic thing. Okay, what we talk. These are the different data types available for you. These are the different data types available for you. Okay. Now, let's see this one. Okay. Now let's open our program and start doing something. Okay. Let's see. Okay. Okay. Now, first, what are the different types of data types? I told you byte, short, int, long, float, double, char, boolean, and string. Right? We're going to see everything. Okay. Let's do the byte first. Okay. How you declare a how you define a data variable is like first you need to tell the data type what type of data the variable is going to hold, which is going to be byte. Okay. And then any variable name. Okay. The convention for the variable right this. Okay, the convention for the variable name is like it should always start with the character. Okay, variable name should start with the character. Okay, and that's the first rule, and it is alphanumeric. Okay, when I say alphanumeric, right? Once you start with the character, then you can have numbers, digits inside in it. Okay, and then only 2 symbols are allowed. Okay, 2 symbols are allowed. One is underscore. When I say forget about the single quotes. Okay, one is underscore and another is dollar. Okay, where is the dollar? Yeah, dollar. Okay, this is the convention for the variable name. You can have any number of characters you want, but don't get don't use like 20 or 30 characters as a variable name, because you need to use variable names in your program down the line. Okay, so make it always sensible. Okay, that's how they will work. Okay, so it will be easy for you to remember down the line. Okay, let's call it as when I say the variable name, like it can be like this. Okay, byte presentation this is a perfectly valid variable name, okay, but this is going to be too big actually, okay, so I'm just going to call it as b for the moment, okay. Now if I start with the, as I said, like, no, it should always start with the character. If I type 1b, right, it will show error because it's not a valid variable name, okay. So I'm just going to call it as b at the moment, okay. Now what is this, now this is, now what the b represents is like, no, in your program, right, in your program you can use b to store 1 byte of data in it. When I say 1 byte, it's 8 bits, and it's not really 8 bits only, it's only 7 bits. I told you why it's only 7 bits, because the most significant bit, the first bit, is always used to represent the signature of the value. So you got only 7 bits to represent the values, okay. So you can, so in this b, right, you can either have a least value of -128 to the greatest value of 127, okay. That's the maximum value what you can have, okay, and it goes on like this, okay. So byte has got 1 byte, okay. So you can have just right, okay. You can have -128 to just remove this, okay. -128 to 127, okay, and then it goes on like this, okay. 1 byte, 2 byte, 4 byte, 8 byte, okay. For 2 byte, right, it's really hard to calculate. I'll just do another different way to show you guys, but don't worry, I'll tell you what these things are, okay. Okay, so the minimum value of a short is this one. It's this one. Always see this one, okay. So in this one, when I say 2 bytes, it's got 16 bits, okay. This is the maximum number you can, again, in the 16 bits, 1 bit is the most significant bit, that is the first bit, is reserved for the sign bit, okay. So you got only 15 bits to represent your values, and this is the maximum value what you can represent using 15 bits, okay. And then it goes in the reverse order also, okay. So I always told you, right, like, no, why no, I didn't tell you why it is it's one more than this one, but just think it is like that, okay. Because the reason is, again, I will tell you something called as a concept called as 2's complement, okay. I wouldn't recommend to look up it, but if you really want to know why it is one value is more than the positive, right, just look up on it, okay. 2's complement, okay. And now and then I just wanted to quickly tell, okay. So it's really simple, okay. So we saw 100 is 8, right, okay. If this in a byte, if you store 8, means like, no, how it will be stored is like, no, it's stored like this, because these preceding zeros doesn't have any value at all, okay. So it's all zeros, okay. This is how this is the value. So if I do I'll write this base 2 equal to 8 base 10, okay. Now okay, so this is how 8 is represented, okay. Now if you want to represent -8, like, now how it is represented, it's exactly the same thing, but just one, as we discussed, like, no, the most significant bit will be flipped, okay. 0 0 0 1 0 0 0. Okay, this is how it represents, okay, because this bit this bit, right, it's always reserved for the signature, okay. So you shouldn't take this into consideration when calculating the values, okay. So you should take only the least significant 7 least significant bits, okay, to when calculating the value, okay. So that's how this is how the 8 is represented. This is how the -8. The only difference between the representation of 8 and -8 is the most significant bit will be flipped, okay. In this one, in the positive scenarios it will be 0, in the negative scenarios it will be 1, okay. That's it, okay. And then the same thing goes for here also, okay. So because why I started with byte is, byte is easy to explain, but this int long and all that, it's too much to explain, okay. It's too, because the values explode exponentially, okay. if you look at this one, it will be in some, the maximum value will be in somewhat in 2 billions actually. Yeah, see this one, right? Okay, I'm not going to type what's long is, because long is very huge. Okay, okay, it's pretty huge. Okay, there will, I mean, I can't say there will be a scenario, but in our day-to-day program, like not in only in extreme cases you may need something bigger than this. Okay, this value looks like a it's bigger than our phone number. Okay, if it consider as a value. Okay, so you will never require a mathematical value. You will never require a variable to represent a mathematical value greater than this one. So that's why long is a most highest thing what you will use. Okay, pretty much we will use int as a most common thing. Very rarely people use byte and short actually. Okay, yeah, because it can easily cross 32,000 is a I mean it can easily cross 127, because when you're doing mathematical calculations. Okay, and it can easily cross 32,000. Okay, so they pretty much use int as all for all their purpose. If they know for sure, if they know for in some circumstances where it's going to cross beyond this one, like no, then they will use long. Okay, so int and long is the most commonly used things. Okay, now, okay, it's simple things. Okay, now, okay, byte is equal to, if I do this, I can do this. This is called as definition, and this is called as declaration. Okay, I've defined this b is going to be byte of data type, and then I declared it with the value of 12 is the starting. Okay, if I print out this one, b means like control, you'll get a value of 12. Okay, it's pretty simple as that. Okay, because b represents 12. Okay, you can change b at any time you want. You can change it as 13, and then again now it will come as 13. Okay, now we can do this. B is equal to 14. If you do this, first you'll get the, because at this, when this line was executing, b value was 13. When this value, when this statement was executing, the b value was 14. Okay, that's why you get 13 and 14. Simple as that. Okay, now have one more. Let's do one more byte variable. Okay, let's do that. B1 equal to 13. Okay, now again the same thing. Okay, you can have as many number of because this is one way of doing it. Another way of doing it is byte b equal to 12. It's going to complain. Yeah, byte b1 equal to 13. Just comment out this statement. Okay, this is exactly same as this one. Okay, because this uses many number of lines. Okay, if you want to have 3 variables or 4 variables of byte, like no, you don't need to do it in a different line. Okay, you can just in a single line you can say this one. So what this means is like now there's going to be a b of data type byte, and then the initial value is going to be 12. Again the same thing, there's going to be a variable called as b1, which is going to be of type byte, and then it's going initial value is 13. Okay, it's as simple as that. Now what's going, if I do this, right, if I do b equal to b1, right, and then change b later, right, b equal to, let's do b plus 1. Okay, now yeah, no, why it's not allowing. Okay, so b plus what this plus plus means, like now it's really simple. You will use it every, they call it this plus plus as incremental statement. Okay, incremental statement is nothing but b plus plus is equal to b equal to b plus 1. That's what this means. Okay, b plus plus means it will increment the b value by 1. Okay, that's it. Okay, now so if you have incremented the b, but the b1 will be now what you have done is like, now let's do print out this one. Okay, see what it actually everything is telling us. b1 statement. Okay, and just remove this thing. It's really simple. So what we have done is like now we have declared two variables. Yeah, one is b and b1, and then I've printed out b and b1. I'll get 12 and 13 again. Now what I've done is like now I've assigned the b1 with b, which is going to be, so the b1 is going to change from 13 to 12, and when I type, I'm going to get 12 and 12. When I increment b, right, b is going to change as 13 and b1 will remain as 12. Okay. So if I run this, right. Yeah, okay, the first two statements. Okay, so we know b is going to be 12, so that's why you're getting 12. Now b1 is become b1 is initialized 13, so you get 13. Okay, now you have just assigned the whatever value in the b into b1. Okay, but they two are two different memories. So what will happen in this step, like now just b will be copied over to b1. After that, like now b won't have these two won't have any relation between each other. So b is before this step b is independent of b1. After this step also b is independent of b1. Okay, all you have done is like now just instructed the Java to copy the value in the b into b1. That's it. Okay, so after this step, right, both b1 and b will become as value 12. After that, when you increment b, right, b will become as 13, but b1 will remain as 12. Okay, that's oh sorry, no, you don't need to do this. Okay, so just this one. So okay, so that's why you see this, right? In the second step, both are become 12, and then in the third step, b is incremented 1, and then that's why it became 13, and then it became 12. Okay, that's it. It's simple as that. And then now we just saw byte, right? You can go over everything like this. Short s equal to 12 s. Again, you can go integer int is equal to I equal to any values, I mean, blah blah blah. The only difference between byte, short, and int is, you know, this has got 1 byte, this has got 2 bytes, and then this has got 4 bytes. I'll get to it, and then there's something long as well. Okay. Now what is long is it's got 8 bytes to it. Okay. Blah 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 blah. You can have bigger values like this. Okay. Now let's see another important thing. Okay, now what I told you was like, no, there is a limit, right, of byte. I'll just remove all these things. Okay, now in the starting of the class, I told you like there is a limit for everything, for every representation. Okay, so what we put down here is like, this is the minimum value what you can store, this is the maximum value what you can store. Okay, now let's see what happens if we store a bigger value of 127 is allowed. Okay, perfectly allowed. Okay, type this, right, you'll get 127. Okay, if you do 128, right, see, Java itself won't allow. Okay, because I'll tell you in a couple of minutes later why the error is like this. Just remember this, because Java itself is not allowing, because Java itself knows that in a byte, like, no, this is not a byte represented value, because you can't represent these values in a byte. Okay, that's why it's complaining. So what we are going to do is like, no, I'm going to do something called as typecasting. Okay, I'll explain what is typecasting. Okay, in later. Okay, because this at this point of the session, right, I just want to explain you what will happen if you try to store 128. Okay, after that I'll explain to you about the typecasting. Okay, if you try to store this one, right, the value will become as minus 128, 128 will become as minus 128. Okay, see this one, right? Isn't it magical? Okay, if you go 128, it will become 127, and it goes on. Okay, like this. I'll explain to you why it is like that. Okay, now what has happened is like, now when you go over beyond, right, what okay, let's say what is 127. Okay, where is my whiteboard? Okay, here, what is 127? Okay, 127 is nothing but 7 bits of, okay, let's do an 8-bit representation. Okay, so it's going to be 0, because why I said 0 is like now, because I'm talking about I'll just do positive 127. Okay, I'm going to represent this one. Okay, so now, so 0 1 1 1, and then 1 1 1 1. Okay, so 4 ones and then 3 ones, so 7 ones represent 127, and then this 0 represents, it's a positive value. So this is the maximum value you can have. Okay, what will happen if we add 1 to it? If you see, this means like, no, so everything will become 0, 0 0 0, and then this bit will become 1. Okay, this is what will happen if you try to go beyond 127. Okay, 127 will become 128, and then 1 added to it, and then the most significant bit will get affected. Okay, and then it will become a negative value. Okay, in I told you about something called as a 2's complement, right? That's what, because of that only, like now you're getting as minus 128. So if you go 128, right, it becomes minus 128. Okay, now no, this is 127, and so this is 127. Okay, this is 128, and what is 129 is like now. Again, why this become, okay, 127 remains as 127 itself, okay, in the byte representation, but in the byte representation 128 becomes as minus 128. Okay, sorry, minus 128, and then 129 becomes as minus 127. Okay, why this becomes as minus 127 is like now, because I told you before there's a concept called as 2's complement. That's why the reason is, when I'll tell you what is 2's complement is. Okay, 2's complement is nothing but flipping all the bits and adding 1 to it. Okay, now okay, now it'll become too much. Okay, if I start explaining what is 2's complement and go there. Okay, because it'll be quite out of scope. You will never recur it actually in your programming. Okay, because in the C programming world we used to do that. Okay, that's why it's called as. Okay, now this concept is called as like, no, once you got 127 and once you store 128, right, the simplest thing how you can remember is like, no, simplest thing how you can remember is right, so if you do this one from, and then it goes on, and then you get 0 1 2, and then it goes on, you get 127 and 128. Okay, so this is, I'm going to do byte representation. Okay, so let's do decimal first. 128 and then 128 and then 129. Okay, and this is a normal representation. Okay, in the byte, right, minus 128 is minus 128, and minus 127 is, you can, because why I'm saying is minus 127, right, because you can represent minus 127 128 minus 127 minus 126. Okay, and it goes on, and again you can represent 0 1 2, and then goes on. Again you can represent 127. Okay, now when you try to represent 128, right, what happens in the byte, right, after 127 it will overflow. When I say overflow, in the sense like, it will go back to its start. Okay, because in a byte, right, this is the start and this is the end. Okay, if you go one step beyond what is the maximum start is allowed, right, it will go, sorry, maximum end is allowed, right, it will go back to the start. Okay, so again it will start from this one, minus 128 and minus 127. It keeps on going like this. Okay, if you can keep going as much as possible. Okay, you can go like this, and then if you go to 256, right, what will happen is like now it will reduce minus 127, and then it will keep on reducing and then come back to 0. Okay, and then if you put another, say for example, come on, 257, that is represented as 1, and then you can go like this continuously forever. Okay, and then what is the next 120, if you add 127 to it, right, what you will get as 37, no, 384. Okay, now if you do 384, right, which is 127. Okay, if you do 385, again what will happen after 127, because your 384 is already represented 127. So sorry, in the step of 385, what they're trying to do, they're trying to go one step beyond the 127. So again it will reverse back to the original. Okay, so that's how you can try to store as many big values as in a byte. Okay, but it will never allow you to store beyond minus 128 to 127. It will always overflow and revert it back to original state. Okay, let's see this in the programming phase. Okay, so let's see it in here. Okay, Now I stored what I've told you is like, no, I stored 125. Okay, if I try to store 256, right, you'll get a value of 0. Okay, so that's what I told you. Okay, 256 represents 0. Okay, where is it? 257 is 1. Okay, and 384 is 127. I hope my math was correct there. And I go on beyond 128. Yes. Yeah, this is 127. Okay, so, yeah, my math was not right. 3. Of course, it is the odd number is odd number and positive. Yeah, okay. Odd number is odd number. Yeah, okay. Now, what I told was like, no, even number will be always be even number, odd number will be always odd number. Okay, so that's why earlier I had like this, right? So even number can't be odd number. That's why I said. Okay, now, okay, 383 is 127, and then if you do 384, right, it has gone one step beyond what. Okay, and it will go back to 128. Okay, minus 128, and then this process will start. If I do 512, it will go back to 0. It will be 0. Like that. Okay, because I'm gone. You can go as many as, and then this concept, right, this applies for everything: byte, short, int, and everything. Okay, so say for example in the short, right, 32761 is a maximum value. If you try to store 32768 in the short, right, it will become as minus 32768. Okay, let's do that here. Okay, I'll just remove this one. Right? Again, typecasting is involved. I'll tell you what is typecasting is. Okay? Now, if I do this, right, you see, it has reverted back. You try to go one step beyond, and this goes for int also. In int, right, this is perfectly valid value because you can represent 32768 because it lies well within this limit. Okay, now if you try to go over beyond this limit in the int, right, this is the value and this can be easily represented. Okay, if you type it will print out this value. Okay, but if you go one step beyond this value, right, it will become negative value. So I have to do long. What I'm doing, send only. Java itself is not allowing it actually. Is it IntelliJ or Java itself is not allowing? Okay, Java itself is not allowing you to store beyond this value. Okay. Integer number is too large. Okay, okay, that's fine. And then you can have minus 126. This is a perfectly valid. I guess if you go one step lower than this, again Java is going to not allow you. Yes, okay, integer number is too large. I mean, it's not too large actually; it's too low because 9 is lesser than the 8 actually. Okay, yeah, here there is a problem with IntelliJ itself because the statement is not true actually because integer number is not too large, integer number is too low, you should say. Okay, now. Okay, this is how it works. Okay, so this is the maximum values what you can store in each thing, and then for long also there is a limit. Okay, now let's see what is float and double. Okay, float and double, it's nothing but which is used to represent that decimal values. Okay, when I say decimal values, the real numbers. Okay, so if I remove this one, right, I still haven't told about data types. Sorry, not data type, typecasting. I'll explain to you what is typecasting is. Okay, now let me remove this one. Okay, now, so what is float and what is double? Till now, I assume everyone is clear with the concept of byte, short, int, long, and why this is the maximum values it can store. Okay, now let's talk about float and double. Okay, float and double is a really simple concept. We don't need to go into this kind of thing for the float and double. Okay, for the float, right, float is used to represent the decimal values. Double is used to represent decimal values bit bigger than the float. Okay, where there is a circumstance. If you do float, you can do f, and then you can have 2.3 like this. Okay, so and you should type f. Okay, I'll tell you what the f and d means. Okay, for the float and double alone, like no, you don't need to, but for the float you need to. For the double, it assumes by default. Okay, for the float and double, right, whenever you're putting a value there, means like no, you need to end with f or d. Okay, for it's f here, end with f, end with d. That's it. Okay, because you need to tell it is going to be a double, it's going to be a float. Okay, so that's what. So 2.3 is the actual value, and I'm just put f here to say that it's going to be a float, and same thing goes for the double as well. Okay, 2.3, you have to just do d. You can d, but d is not always necessary, because by if you don't do d, means like, by default it will take it, it will assume it as d. Okay, that's why. Now, okay, that's it. It's simple as that. Okay, let's see what is the maximum value we can store, because float has got 4 bytes and double has got 8 bytes, so that must be a difference to it. Okay, let's see what's maximum value. Maximum value. I need this. So e to the power minus 48, in the sense, into 10 power of minus 45. Okay, so it can this is the minimum value of the float, and this is e to the power of 38. So you got like 38 the same character digits. That's pretty huge number. Okay, that's a float, and if you say double, means like, it will be astronomical. Actually, it will be very, very huge actually. Minus 324. Yeah, okay, it's 308. I'm pretty sure you will never require any value which is going to represent more than 308. Okay, e to the power 308. Okay, so this is the maximum value so you can store. Okay, so that's pretty much simple. Okay, and let's see what happens if I try to store that floating values in the integer. Okay, because we know for sure, like, no, integer can have only whole numbers like this. Okay, 3 or 4 like this only. Okay, it can't have 4.4. Okay, because you're having a decimal representation here. Okay, let's see what happens if I do this. Okay, it will come as 4. Okay, 4.6, it will come as 4. The reason is like, no, it won't do any kind of intelligent thing saying that, okay, 4.5 4.6 is greater than 4.5, so the nearest number is 5. It won't do like that. If you do 4.3, means like, no, oh, the nearest number is 4, so I'll represent. It won't do anything like that. Okay, all it does is like, no, it just removes the decimal value and stores in the int. Okay, that's all it does. Okay, so if you type to store 4.6, it will come as 4. If you try to store 5.6, it will come as 5. Okay, that's it. That's it to it. Okay, and let's see what is character and boolean as well. Okay, let's see first boolean. Okay, boolean is really, really simple thing. Okay, just remove this. Okay, if you type boolean, right, you can either have true or you can have false. These are the only two things. Okay, you can't have anything like this. These are not allowed. You can't store values. You can't have anything like this. You can just have either true or false. Why this is useful is like, no, this is really useful for the in the conditional statements. When I say conditional statements, right now, to prove whether a statement is true or false. Okay, to represent that one, these kind of things, the boolean variable is really useful. Okay, down the line. Okay, now what is character? Okay, character by name itself, we know that, like, it used to represent the characters. Okay, character c equal to, if I do this, right, you can have any single character you want, but you can have only one character. Okay, that's most important. Okay, a, or you can't do like this. Okay, you can have only one character. You can have any character, or you can have any number also. You can have any symbol also. You can have anything. Okay, but it should be one character. Okay, Now let's see how this works. Okay, the concept of this works. Okay, we know only the in this one, like now we saw how a binary in our previous things. Right now what we saw is like now how a binary is. I think we can go for the previous ones. I think if I erase it to okay, forget about it. Okay. Everyone knows we all know that one, right? How yeah, how a decimal value how a value decimal value is represented in a binary format. Okay, now you may ask, okay, how a character will be represented, because how what is the conversion for a character into a binary statement? Okay, there isn't anything. Okay, it's really simple. Okay, all the characters, right, they have a equivalent of decimal values. Okay, and those decimal values is used to represent the characters. Okay, represent the characters. Where that is defined is like, no, if you go to Google and type data type, sorry, ASCII table, right? So this is the representation. Okay, what is our character? Okay, if you type a character, if you try to store a character, means like, no, what it means for computer is like, no, it will be converted into a decimal value which is 65, and then which will be converted into a binary value. Okay, and binary value of that one is not this one. Okay, binary value, we know how to create a binary value from 65. Okay, so every character will have a decimal representation, and then decimal representation will have a binary representation. Okay, so whenever you try to store a character, right, first the character will be converted into a decimal value, and then the decimal value will be converted into a binary and stored in the memory. Okay, that's how the storage of A works. Okay, so when you say D means like, no, it really means is like, no, where is D here? It really means 100. Okay, I'll tell you how it works. Okay, now okay, let me we haven't talked about typecasting yet. Okay, I'll do this. You can typecast it as, you can store it like this, and then if I print out the I, right, what I will get is, I'll get this value. Okay, 100. See this? Because this is ASCII representation. Okay, usually the ASCII tables only goes till 126, 127. It should go to 127. Okay, because those are the most common things used. There are different language. So in this one, like, no, you can't see any other language. Okay, you can see only English, A, capital letters and capital. There are a lot of other languages. Say for example, there is a what language? There is a French, there is German, there is Polish, there's Hindi, Tamil, Telugu, all languages are there. Okay, everything has got its own representation. So 126, right? 126. What is the binary require? What is the amount of data amount of bits you need to represent 126? It's 7 bits, which happens to be 1 byte. Okay, so if you go to 2 bytes, what I told you here is like, no, a character has got 2 bytes in it. So what you can store is like, no, it can have these many decimals. Okay, these many representation. And the good thing about the character, right, it doesn't have a negative representation, so it just needs a positive representation. So 2 byte is like, no, it's 0 to, I think, assume all the bits are ones. Okay, now it will be at 1 second. Wait a second. I think it will be 5. So because you don't need a negative value here, because in the character world, right, there is no negative values. All you're going to have is like, no, ones and twos, and every single character you just need a decimal equal representation of it. Okay, so that's why 2 bytes is not represented -3 to this one, because you can use all the bits. There is no in the short, int, byte, long, everything, we know that the most significant bit, the first bit is reserved for the signed bit, right? In the character there is no such thing as signed bit, so that's why you can use the whole 2 bytes to represent a value. So that's why you have 0 to 6335, because there is no most significant signed bit, right? So you can't have there is no negative representation. If you look at this ASCII table, right, it will start from 0 and then decimal. Yeah, you're not see, they're not doing the whole thing actually, because I think zeros and all represent the sound and all those things actually. Yeah, there is a ding will be there. See this one bill, right? If you in the C program, it's a cool thing actually. If you try to print out 7, right, into a character, right, you'll hear a sound called as bill sound, ding sound actually. Like this my phone did, right, like that. So 127 is delete button. Okay, so when you press, okay, now this is how you know the keyboard, right? Keyboard has got all the characters here, right? When you press the delete button in your keyboard, right, what your keyboard will do is like, keyboard will convert the button into 177, sorry, not 177, 127, which is decimal value, and convert that 127 into binary representation, which is 111171 okay, and it will send that binary representation to the to your CPU or your computer, because the communication between the keyboard is separate instrument, okay, and CPU is separate instrument. The communication between the keyboard and the CPU also works in a binary format only. So when you press the delete button, right, delete button won't go as, oh, delete, not like that. It should go as ones and zeros. Okay, how that ones and zeros is represented is like, delete will be converted into 127, and here it is a binary representation. So 7 ones are there. Okay, and in the same way, when you type, you got all this. If you press shift 1 means like, now it is exclamation, right? Shift 1 is, right? So when there will be exclamation representation here somewhere. Okay, when you type the shift 1, right, or the computer will, your keyboard will send 1000001 to the CPU. So the CPU will understand, okay, the keyboard has sent this one, so I have to use exclamation to whatever I'm doing at the moment. Okay, that's how the computer works. Okay, the real-time computer works. Now, okay, now I'll show you one cool thing. Okay, what is the maximum we did? 655. Where is that? Don't worry, we will see all these things. Whatever I'm doing, actually, I'm just trying to demonstrate something here. Okay. Now, I told you, right, all the characters in the ASCII table represents only the English characters. Okay, but in Java, right, because it's so big, right, we can represent all the characters existing in all the languages in the world. Okay. What I'm doing wrong? Oh, sorry. I'm such a big idiot. Okay, now let's see. I know for I think it's 299 some print out the intros. Why I'm using I again and again? I should use J, because J is our. Okay, now let's see. If you go to 2900 something. Yeah, you see this, right? These are all Tamil. Sorry, these are all Tamil characters. Okay. If you don't know who's we got okay. So if you see this, right, these again Tamil is continuing. I think it's somewhere. I think this is. I'm not sure if it's Telugu or Kannada. So you got and this is Kannada. I think after Telugu, Kannada comes actually. So like this, like, no, if you go down, right, all the languages are represented here. Okay, these are all. We don't know what these languages are, but I'm pretty sure Chinese will be there, Japanese will be there. Okay, see this one, right? It can be either Chinese or Japanese or Korean. We don't know what this is, but all the characters are represented. Okay. So what I've done is like, now what this program does is like, no, I have asked it to print from 0 to 635 their equivalence character representation. So that's what we have done. Okay. Now let's see. Okay, we used to do this thing in the, so let's see. Okay, what this ASCII value says is, There is a match I will ask you. Okay, see, 65 says it's A. Okay, if you look at 65, right, that will be represented as A. Okay, that's how. This is what the ASCII table is. Okay, now this is how character is represented, but this is just information what you should remember, because you will never really use character in your program. Okay, you will always use a string. Okay, which is string. When I say string, is because you're not going to never going to use a single character. You will always use string. Okay, which you have bunch of characters appended to it. Okay, now let's remove this one. Okay, all these things, and then do string. Okay, at this point, right, I'm not going to go deep into string. Okay, because in the later sessions, when after I do the objects, right, we will see deep into strings. Okay, at this point, right, all you do is like, no, just remember in a string, right, in a string, right, string is the data type and variable name is anything str. You can do like this. Okay, you can have key, you can have this, you can have anything like this. Okay, you can have a whole bunch of strings to it. Okay, now you see this one, right? To represent a string I use double quotes. Okay, and to represent the character I use single quotes. That's the main distinction you should remember. Okay, to represent character, right, you should do this, and then you can do this or this. Okay, you can't use double quotes to represent the character. Okay, it will immediately complain, because it will say that it's not a string. Okay, because only string is represented in single characters, so double quotes. You can't use single quotes here. A single character, you can't use single quotes because too many characters in a character literal. Because you are allowed to in starting itself I told you, in a character, this means that, like, no, this is going to be a character, the inside is going to be a single character, but you have got multiple characters. That's what it's whinging about, that's what it's complaining about. So that's why to represent a string you should always use double quotes. To represent a character you should always use single quotes. And you can forget about the character, because only in my initial stages of programming, right, I used characters. After that, we never really use characters once we moved to Java. Okay, but you should know that something exists. Okay, I'll quickly tell you why this is in different color, why this is in different color. Okay, this is the character, and you see these things, like, no, why they are in different color is like, no, the blue color represents, like, no, they are called keywords. Keywords are reserved in the Java. Okay, you can't use those keywords for any other purpose. Okay, if you type Java keywords, right, it will tell you what are all the keywords are there in Java. So all these things, like, no, these are all keywords in Java. You can't use it for any other purpose, because they already have a fixed meaning to it, what they mean. So you can't change the meaning of it. So that's why it's in blue color. Okay, that's what they call it, because character means it's going to represent a C. Okay, so that's why it's called as this thing. We know here string means a string, but string can be manipulated. I will tell you how it can be manipulated, but you can't manipulate this definition. Okay, this character means it's character. Okay, so that's what they call it as keywords. Okay, all we have seen now is like these things. Okay, we saw short, we saw int. Int must be hiding somewhere. Int, everything will be there. Double, float, double, and then float. Everything will be here. Okay. Now, so pretty much this is what the different types of data types are available for you. Okay, this is what the variables are there. Okay, now, okay, what we have done is, okay, so we have seen byte, short, int, long, float, double, character, boolean, string. Okay, so byte, short, int, long, these are all used to represent whole numbers. Okay, they just have different sizes: 1 byte, 2 byte, 4 byte, 8 byte. So that, like, you can go from different values. Okay, and then float and double, they are used to represent the real numbers. When I say real numbers, they can have decimal part, which is after dot. Okay, so again the difference of float and 4 bytes and 8 bytes. We saw what float can. So it was in e to the power 38, and double was in e to the power 308 or something like that. It's too big actually. Okay, double. So you will never recur. You must never, in your day-to-day programming, right, you never come to a situation where you require more value. You want to store a value greater than the max value of double. Okay, and then character, what we saw, character was like, no, it represents a single character, and the character, we may say it as a character, but internally it is represented as a integer value, and then integer to binary. Okay, boolean can have only two things, which is true or false. Okay, and then string is collection of characters. I'll just put it like this. Okay, now, okay, string is and then you use double quotes to store the string, and we use single quotes to store the character. Okay, now, I hope everyone understood what the different types of data types and variables. Okay, now let's see, because I was using a word called as typecast a lot of times, right? Let's see what is typecasting means. Okay, what is the literal meaning of typecasting means? Typecasting means like no, you are trying to typecast someone means like no, that person is trying to, he is representing something different, but you are typecasting into a different person. Okay, so that's what so if how do you say that, by okay we say like by looking at his face itself like no, I will know what language he speaks. So what it means is like no, you really don't know what language he speaks, but you are typecasting him that he will speak certain language. Okay, that is what called as type. That's a literal meaning of the typecasting, and in programming also it assumes like that. Okay, so what you're trying to do is like now you're trying to change a definition of something. That's what is called typecasting in our concept. Okay, now so you say for example you got a byte variable, okay, b1, which has got 12 here. Okay, now you got a short variable, okay, which has got s1, and then it has got 13 stored. Okay, we know, sorry, no, let's see 256 stored in it. Okay, now we know that we can't store 256 in b1, and 256 is a perfectly valid value in s1. The reason is because short can represent anything between minus 32768 to 32761, and 256 falls well between these two. Okay, so that can be represented by short, that can't be represented by byte, because that 256 lies outside of the maximum value. Okay, now what if you want to, but you don't really care, but you still want to store the s1 into a byte, right? That's where you have to do the typecasting. Okay, now what I'm trying to do, so yeah, I have one more thing like this. Okay, now b1 is equal to b2. Sorry, that's a perfectly valid statement, because all you're trying to do is like store a byte value into a byte. But if you're trying to store a short value into a byte, right, it won't be allowed. Okay, it will say that because I am expecting a byte here, but you are trying to store a short. Okay, so in that circumstance, Java will always complain. In that circumstance, but you really want this to happen, you for some reason you want this to happen means like no, then you have to do the typecasting. Typecast is nothing but in the brackets you just need to say what it needs to be typecasted as. Okay, so you want the short to be typecasted as a byte, so that's why you're doing it as a byte. Okay, so now this becomes a perfectly valid. So what the Java will do is like no, it will take the s1 before storing it, right, it will typecast it as a byte and then try to store it as and it will store it in the b1. Okay, you can typecast anything into anything. Okay, you can typecast into anything, but again it will become a wrong statement. So what will happen is like now, so you have typecasted this s1 this short in as an int, but you are trying to store that into a b1. See, it's not complaining anymore about you're trying to store a short into a byte. It's complaining that you are trying to store an int into a byte, because you typecasted this int short as an int. Okay, if you remove this typecasting, right, again it will go back to complaining you're trying to store a short into a byte. Okay, once you do the typecast, right, this becomes this s1 becomes as an int, the statement becomes as an int statement. Okay, so that's why it's complaining about you're trying to store an int into a byte. Okay, now let's go back to, so what we are trying what we want to achieve is we want to achieve we want to store the s1 into a b1, which happens to be short, and we want to store a short into a byte, so we use byte. Okay, byte as a typecast. It's as simple as that. Okay, if you, and we all know that what happens if you try and store 256 in the byte, right? Because if you try in s1 it is represented as 256, but in the byte world, right, 256 is represented as 0, which we saw here. Okay, so if I try to print b1, right, it won't come as 256, it won't come as 0. See this one, right? That's how it works. Okay, and now what you have done is like there's something called as implicit and explicit typecast. Okay, now you see this one, right? If I try to store Again, this is why it's not complaining. So because here it is complaining. When you're trying to store a short to a byte, it's complaining. But when you're trying to store a byte into a short, it's not complaining. There is a perfectly valid reason to it. The reason is like, now, when you're trying to store a short to a byte, right, there is a possibility you might lose values. When I say lose values, it's right now because in short it is up. You can have huge values than byte. Okay, in short, if you have 256 and if you store it in B1, right, you will lose values. When I say lose values, it's like, now you may by mistake think, okay, oh, short I have got only 13, which is a perfectly valid, can be represented as in a byte as well. So this statement I would think proper, but because of some circumstances, 13 has become 256 in your calculation, and if you try to store this one in your byte, right, it will become a 0. So what it means is like, no, when you try to store a bigger item into a smaller item, right, you are always going to lose some values. Okay, that's why it's not allowed. But if you try to store a smaller item into a bigger item, right, you will never lose values. When I say that, means like, no, because in the B1, right, already you can have only values between minus 128 to positive 127. But short can easily represent anything what byte represents. Okay, if you go to the table back, right, so whatever byte represents, right, it can be represented by the short as well, but the other reverse is not true. Whatever short represents, right, it can't be represented by byte. That's why it's not allowed. You have to implicitly say that I need this to happen, please allow me to do it. That's why it's called implicit and explicit typecasting. Explicit typecasting is going from trying to store a smaller into a bigger one, which is perfectly legal one. That's why you don't need to explicitly say, but you can still say it's nothing wrong with it. So you can just say it as short. There's nothing wrong in it. It's perfect fine, but you don't need to say it. If you don't say it, means like, no, what Java will do, like, no, Java will immediately put short for itself. Okay, but why it's not doing byte here by automatically, right, because the reason is like, no, it needs to tell you that you're going to lose values, be careful in programming. That's why it's not allowing you to do it actually. So if you still want to happen, right, you need to implicitly say that allow me to happen. Okay, this is what this step is called, implicit typecasting. This is called explicit typecasting. Okay, you don't, in explicit typecasting you don't need to say anything, and implicit typecasting you need to say that. Okay, and the important thing is like, now this typecasting will be used a lot in the down the line when you do the programming, when you do the automation, right, it will be used a lot, but not at the integer level or the object level it will be used. So that's why I want to understand what typecasting means. Okay, so that we can use it in a later circumstance. Typecasting nothing but you're trying to a variable has got its own definition. Okay, and you are trying to convert that variable into a different variable, different definition, means like, no, that's where the typecasting works. Okay, so if here what you have done is like, no, you have typecasted s1 into a byte and then stored it in a b1. After this statement, right, s will still be a short. S won't be converted to a byte. Only for this statement, right, only for this statement s has been converted to as a byte. But after the finishing of this statement, right, s will still be a byte. S will still be a short. Okay, it won't convert to byte magically. Okay, so if I do this, right, find control. If I do this, right, I will get 0 on 5 12. Okay, because what you are trying to do is like, no, S1 has initialized as 256, and I will try to store the 256 in B1, and we know that 256 is equivalent to 0, and so that's why you are getting 0, because B1 is short, B1 is byte, and then you are trying to store, after this executing of the statement, right, short will go back to being short itself, and then because in the short you can have values more than 127, so you are having 512 here. Okay, if you store 512, which is a perfectly valid statement, and you can, when you print it out, it becomes as 512 itself. Okay, this is what the typecasting means. Okay, this is what the typecasting, and it goes for everything. Okay, you can do byte to short, short to int, short, long to short, float to double, float to int, float to short, everything is allowed. Okay, so now let's do decimal into this one. Okay, if you do have float as, okay, so I forgot the variable name. Okay, if I try to store f, right, it won't allow, because I'm trying to store a float into an int. Okay, now we have to do a typecast. what I want the typecast to be, I am trying to store a I, right, integer, right? So I need to convert this float into int. Okay, so this float needs to be typecasted as I. Okay. If I type I, I'll get 3, because this decimal part will be, when it's storing, right, this decimal part is it will be ignored, completely ignored, because you are losing values here. That's why you need the implicit typecast. You need to implicitly say that the typecasting is recorded here. Okay. Now the another interesting thing is, let's do a short. Okay, let's do a byte. Okay. Again the same thing. Okay. If you are trying to store a float into a byte, you just need to say that typecasted to byte. Okay. Type here. I'll get 3. Okay. But what happens if I do 256? Sorry, 512. 256.4, because this is a valid, you get a 0, because so what has happened is, so this float is converted into a byte. Okay, so first it will ignore this one, and then it will try to store 256. We know that 256 can't be stored in a byte. It will the overflow will happen, and it will go back to 0. So that's why you're getting a 0 here. Okay. So in this way, right, you can typecast anything into anything, whatever you want. Okay, character and string alone is not allowed here. Okay, because string is not a traditional data type. Okay, when I say traditional data type, these are all called as primitive data types. Why they call it as primitive data type is because these are all borrowed from C and C++. String is unique to Java, so that's why they don't call this as primitive data type. Primitive name itself means primitive, older. Okay, so C and C++ is a parent for Java. Okay, so these are all borrowed from C and C++. Okay, sorry, exactly to be C. Okay, so that's why they call it as primitive data types. Okay, now. So you can't do the typecasting to the primitive data type to a string. Okay, but you can do object typecasting, which you are going to see in the later classes. Okay, now okay, you remember one of the programs I showed you, I typecasted a character into an int, and then I printed out the whole thing, right? There showed you different characters, Telugu, Tamil, all those characters, right? That's what I did there. Okay, now what else? Yeah, I wanted to cover the arithmetic operations as well, right? Yeah, okay. Now I assume everyone is clear in the about the typecasting. Okay, if you have any doubt in the typecasting, right, just let me know. Okay, we will discuss it bit further. Okay? Now, arithmetic operations is a simple thing. Okay, what I mean by arithmetic operation is if you have int I equal to 10, int j equal to 11. If you want int k equals I star j. So k will be 110. Okay. So what the arithmetic operation is? Multiplication. There are different types of arithmetic operation available. One is plus, another is subtract, another is divide. Okay. This is all we know. There is one special thing is available, which is called as modulus. Where is the percentage? Here. Okay. You'll get 0. No. Oh yeah, remainder. Okay, yeah, you will get 10. Okay, so modulus is nothing but, so I hope I don't need to explain what is subtraction, addition, multiplication, and division. Okay, we all know what the arithmetic operation. What is modulus? Modulus is a really simple thing. Okay, just a remainder. Okay, just a remainder of, it's a division operation, but it will just type the remainder. Okay, so what happens when you divide 10 by 11? Don't go into the decimal calculation. So if you do 10 divided by 11, what will be the remainder? It will be 10. It will be 0. It will be 0 will be the answer. It will be the fixed part, and the remainder will be 10. Okay, so that's what you do. Okay, so if I divide by 100, say for example it's 101, and try to divide by 100 means divide by 10 means what result you will get is, you'll get 1, because 101 divided by 10 is answer is 10, the remainder will be 1. Okay, so if I do this 1. Okay, so if I do it by 100, again it will be 1, because 101 divided by 100 is, answer is 1, and the remainder is also 1. Okay, 1 will get 1. Okay, if I do 201, so 201 divided by 100 is, answer is 2, remainder is 1. Okay, so if I do 200 by 100 means the answer is 2, the remainder is 0. Okay, so if I do 99, right, 99 divided by 100 is, answer is 0, remainder is 99. Because you can't divide anything less than the, so if the denominator is greater than the numerator, means like no, then the value is going to be going, it will always start with 0 dot. So the answer is 0, and then you will have a remainder part, big remainder part. Okay, so you don't need to do any kind of division calculation. You can just by seeing itself, you say that remainder is going to be 99. Okay, if you do 101, right, remainder is going to be 1. Okay, you can do like, there is can be complicated things. Okay. 11, apparently 1139 is the remainder to it. So what it has done is like, no, it is a division by this one, and the nearest one it has come is the nearest one division possible is difference is 1139. Okay, that's all to it. Okay, this is what the model is. Okay, so these are the topics I wanted to cover in this session. Okay, pretty much. Let's go to. I'm going to cover something called a scope in the next session. Okay, it's really a simple thing. Okay, so we cover the data types, we cover the typecasting, and then we cover the arithmetic operations. Okay, okay. Sorry, I'm sorry. Yeah, I hope everyone understands what is data types. Okay, I will save all these things and I upload this thing. Okay, so that you can understand. Okay, so what I would recommend is like, no, try and go for yourself to convert one take one like big decimal value like 1136 or 2552 or something like that, and try to convert it into binary value. Okay, and convert that binary value into a decimal value. Okay, how we did here. Okay, so first understand that one. Okay, how the decimal value is represented in the binary is represented in the decimal value. Okay, then go and doing it like now, then go and try to store like now, in your IntelliJ, right? Try to store like a bigger value into a shorter variable and see what happens, how the overflow happens, and then do the typecasting, and just use yourself experimentally to do yours own. Okay, think of different things and try to do it. Okay, I have given some exercises here, and then if you go inside here also, like, there are further exercises in there as well. Okay, so just explore. Okay, the most important thing about these exercises, like, you have to do it. You have to think outside of the box, and then like, whatever you think of, right, try to do those things. Okay, and see what happens. So you try, don't worry about doing something wrong, or so if you do something wrong, then only you can learn. Okay, try to do as many things as possible. Okay, different things as possible, because you will know from each and everything, you will know what is what and what not to do and what to do. Okay, so we have covered data types, we have got typecast, we have got our arithmetic operations. Okay, in my next session, right, I'll just quickly go through a recap, kind of a recap, and then we will move on to the next session. Okay, okay guys, I'm going to end the session here. Okay, goodbye, bye.